Okay, welcome back everyone to part 2. So in the first part we wrote this script called Control1, which I can run again from scratch, and it created the map of the tide gauge site. But now we're going to go into the data, and rather than doing it in one long file, I prefer to set up another MATLAB script, which I'm going to call Control2. So I always like to break it down, and later on we'll set up a README to remind us what each of these is. Now I'm going to cheat and I'm going to copy in my heading again by cutting and pasting, and this M file loads in and plots tide gauge data. This one should have said this M file plots the tide gauge location. Okay. My first step, as always I'm going to do double codes, my first step is going to be to load in the data. So let's go back and have a look at the data. Now I changed my screen resolution since the last video, and hopefully you can see the text a bit clearer now. So let's go back to the text editor, and you can see there's 4 columns of data. 8,784. I know that each data is an hour, so that's the number of hours in a leap year, which is good. The first column is the day of the year, the second column is the observed sea level, the third column is just the tide, the fourth is a surge, and if you add the tide and surge together you'd get this observed one. So this is really useful now. We can start to kind of break this down. Okay, let's load in the data. Now with MATLAB it's very straightforward. If you want to load in data, there's actually a function called load. So you can just type help load, and normally the way it works is you have an output, the function name, and then an input. So our input is going to be the file in. Now let's specify this separately. So our file in is going to be this one. So I'm actually going to right click on it and rename it. I'm not going to rename it, I'm just going to use that as an excuse to copy. And I'm going to paste that in here. But if I was to run this, I'd get an error because I haven't specified that it's actually not in my directory that I'm working in, it's actually up one directory in data. So that's the file name, and then I can call the function load with the file in. Now all MATLAB functions are the same format. You have the name, you have circular brackets, and these are what's input. In this case we've only got one input, and in this case we've only got one output. I'm going to call this D because in my mind it stands for data. So let's run that script, and now you can see we've got this D. We can double click on it and check that it's the same. But yeah, so we've got day, decimal day, water level, tide, and the non-tidal or storm surge or meteorological component. Now you could just work with D, but I'm going to make it a bit easier for us, and I'm going to separate this into the sea level components. Okay, now to make it straightforward, I'm going to call the first one TS, which to me stands for timestamp. You can call it whatever you want. Now, some people would put really long names here, but I prefer to just put two or three letters because it's much. If you use this a lot, it's much easier to type. So I'm going to say TS is D, but rather than doing all of D, I'm just going to extract a component. Now, the first value is the number of rows. So I could say I just want row 1, but actually I want all of the rows, so I can use a semicolon. The next number is the columns, and in this case I want it to be column 1. So what I'm saying here is I want D, but I don't want all of D, I want all the rows, just column 1. And that's going to be my timestamp. And we can run that, double click on it, and we should hopefully see that it is the first timestamp. Now what's quite good with MATLAB is you could say, well actually I just want rows 1 to 10, and that would just make that the first 10. So it's very, very flexible, or you could say I want 1 to 10 at intervals of 2. So this is where MATLAB's really powerful. It's really easy to kind of filter the data and use the data, but we're going to go for all of the rows. Okay, the next one is going to be water level, and notice how I cut and paste just to make it easier for myself. The next one is going to be tide, which I'm just going to call TI, and surge. These are going to be columns 3 and 4. So now I can just run this section and excuse me, and now we have those variables there. We can just check that water level contains the correct one, surge contains the last one, which it does. Okay, now let's bring in a new block of code. And here we're going to plot the data for a whole year. So we're going to plot the whole year, 2012. Okay, so let's first of all just plot water level in the first subplot. So previously here we just had one figure, but now I actually want one figure but with 3 subplots. So I bring up a figure, and the next thing I do is bring up the keyword subplots. And again, you can type help subplot to see how it works, but it needs 3 numbers. The first number is the number of rows, so I'm going to have 3 figures, 3 subplots. Then I need the number of figures in the column, 1, and then the figure itself. If that was 2, it would plot 6 figures. So it'd be 3 rows, 2 columns, but I want 3 rows, 1 column. I can just run that, and you can see it's produced a little subplot. The second one is here, the third one is there. If I change this to 2, you see it would do 6 rather than 3. Okay, but we'll change that back to 1. Okay, I'm going to then hold on, and then I'm going to plot. I'm going to plot the timestamp, the day, decimal day, the timestamp against the water level, and I'm going to plot this in blue. And there is a year of data. And what's really interesting straight away is you can see there's this real big outlier, which is Hurricane Sandy, but you can zoom in and you can start to see the regular tide there. Okay, now always make your figures a bit nicer. So I'm going to add a Y label. I'm not going to add an X label because I'll add that to the final figure because all of the X labels are the same. So here I'm going to put the level in meters. I'm going to put a grid. I'm going to put a box on. Again, just to make it look nicer like I did before. Now you can see it's plotted it all the way up to 400, but I know there's not 400 days in a year. So what I'm going to do is change the axis. But actually I'm going to do something a little bit different now. I'm going to say A1 is a subplot. And A1 is what's known as a handle. And there's lots of properties associated with that handle. If you say, here's the property inspector just loading up in a minute. But if I say get A1, it lists all of the properties that I can change. Sorry, this is just taking a second. So you can see that I can change you can either do it here, but I prefer to do it manually. You can change the X label, the X tick, you can change the direction. There's loads and loads of things that you can change, including the color, the font size, the font layout, various things. But I'm just going to change one property, and how you change is you use the set function. You say which handle I want to set, this particular one, and I'm going to set the X lim, and I'm going to go from day 1 to 367. There's 366 days, but I want to go to the end of that day. And then finally, I'm going to add a title. Water level. Let's be precise. Let's call it the total water level. Okay, there you go. So you can see it's done that really nicely. Okay, now let's repeat that. And again, to make it easier for myself, I'm going to copy and paste. I'll change this to A2. I'm going to make that number 2. Now here, I'm going to plot the tide. And I always try and use the same colours. I always plot the water level in blue, always plot the tide in red. I'm going to change this to B. This is going to be astronomical tidal level. The y-axis can stay the same. Now I'm going to set the second subplot. So if we run that, you can see now I've got astronomical tide. And now you can see each month has a spring neap tidal cycle. The spring neap tidal cycle tends to be higher at the equinoxes, which you see there. Okay, and then I'm going to do the third one again. I'm going to do the third one, change that to A3, change this to A3. Here, I'm going to plot the surge, and I'm going to plot it as green. Make this C, and this is the surge level, or the, technically you should really call it the non-tidal residual, in brackets I guess we could put surge. Okay, now I hate this MATLAB green, particularly in presentations. It doesn't show up very nice. So rather than putting green here, I'm actually going to define my own colour. And MATLAB defines colours as three things: the red, green, blue, also known as RGB. So first of all, use percentage of red. I'm going to have 0 red, I'm going to have 1 green, 100% green, and I'm going to have 30% blue. And that will just make that green a bit darker. It's much nicer than the default bright MATLAB colour. Okay, so now we plotted that for the whole of the year. So we can just run the script from the beginning, and you can see we've got the whole year there. I'm just going to put a semicolon after these so it doesn't write the results to the screen. Okay, now let's zoom in on October. So what I'm going to do is I'm actually going to copy all of this code. Again, just use lots of copies and pastes. I'm going to change this to 4, plot the data for October. Now, in order to work out when October is, because I don't have dates, I've got decimal days, I found this good website here where it gives you the Julian day number in leap year. So Julian day is just 1 to 306. So we can look at October. It's 275 to 305. So here I'm going to change this to 275 to 305. And I'm going to do that for all three. So you can see once you've written some code, it's actually quite easy to cut and paste. And let's run that. We run that, and now you can see we're getting into October. Now what's really nice is you can see that spring tides, neap tides, spring times, neap spring. One spring is always bigger than the other because of the elliptical path of the moon. We'll do that in week 3. And what you can see here is there's a little storm surge. That must have been a little extratropical storm. You can see the water levels will rise there slightly higher. And here's your big Hurricane Sandy occurring at the end of October. Storm surge of almost 3 meters. You can see it just completely dwarfs the water level there. Okay, so let's zoom in on this. Now you can just zoom in here, but what I'm going to do is I'm actually going to copy this again, but I'm going to plot it a little bit differently this time because I think it's nicer. So rather than having 3 plots, subplots, I'm going to have 2. So I'm actually going to delete the second subplot. So let's call this 2, and that one 2, and this one 2. And what I'm going to do is I'm going to plot the tide first, then the water level on the first subplot, and I'll plot the residual on the bottom. But now what I'm going to do is zoom in to the period that I'm interested in. And I'm going to zoom in for the few days before and after the tide. Let's just focus on the total water level first. So we'll come back to that. Okay, and I'm going to focus in on days 299, a few days before Hurricane Sandy, and day 308, a few days after Hurricane Sandy. Okay, so there you go. You can see really clearly how when there's not much wind, the sea levels are very similar to the predicted tide. Again, we'll go over all of this in week 3, but now you can see this storm surge getting bigger and bigger until, you know, we've got almost 3 meters higher than it should be, and that caused significant flooding in New York, as you can imagine. Now what I want to do is calculate what this actual height was, and you can hold your mouse and see that, but I actually want to get that to return it to me in MATLAB. So what I'm going to do is use the maximum function. So I'm going to go calculate maximum water level. And to calculate the maximum water level, you can use the max function. Like always, you have the function name, the outputs, and the inputs. So I here want the maximum water level is max, and then I put in the water level matrices, and I can run that script, and you can see it tells me the maximum is 5.2608. But actually, I'm going to add a second output here because I also want to find the row number when it's maximum. So I'm going to say row number understroke water level. So again, rather than putting lots of long things, I'm going to put, so this is the max water level and then the row number. And what you can see is if I run this, it tells me that row 7,247. So I could actually go to the day, go down to row 7274 to tell me what day. So it's maximum at day 304. 047 is, I know that's 1 hour. So that's 1 hour on 1 o'clock in the morning on the 30th of, in fact, I can go back to this table here and I can see that that's the 30th, day 304, it's the 30th of October. Okay, now what I'm going to do is actually store that information. And I'm going to come up with a variable called O for output. Now, row 1, column 1, remember the first number is the row, and that's column, is going to be equal to my timestamp, but just, not all of the timestamp, just row number 7,247, which will return that. In fact, we can run this. I can double click on O, and you can see that it's the correct value. Okay, and then I'm also going to store the maximum level in column 2. And it could either be max water level there, or you could just replace this with water level. It's the water level on row 724, which should be the same as this. You can run that, and you can see it's 5.260. And then finally, I'm going to plot the maximum water level. So I can use the plot function, and here I'm going to plot O, row 1, column 1. I'm going to plot O, row 1, column 2. I'm going to plot this as, well, I'm going to first of all change the marker size to make it a bit bigger. Let's go for 10. And then I'm going to change the marker face color to being blue. Okay, so let's run that. And there you can see it's plotted the total water level for us there. Okay, now the next thing I'm going to do is do the same thing but for the storm surge. So let's bring up another bit of text here, plot the data for, plot the water level data for October and find max water level. Now, is that the correct labeling? That's 4, so this should be step 5. Step 6 is plot the surge data for October and find the max surge level. So here now, let's run that. Here you can see I've got the surge on the bottom. So I quite like to have just 2 plots here because then you can really overlay the tide. So let's repeat this. And we can just copy and paste this code, but now I'm going to calculate the max surge level. So rather than having water level, I'm going to put SU for surge. I'm going to change the name of these so they don't overwrite to surge. Notice how I just, don't have long bits of text. And here I'm going to put it into row 2. So we want the surge and we want surge. Now here, I'm going to plot the second row. I'm going to plot it as green, but again, I don't like that default green, so I'm going to put the color before as 0 red, 1 green, and 0.3% blue. So let's run this in advance, and then run the next section. And we have an error in the code. Okay, so let's work out what the error is as. Invalid data argument. Oh, I've got an extra color here. I just need the marker face color. Okay, let's run in advance, run section, and there you go. So the maximum surge is actually at exactly the same time. Oh, remember I haven't changed the scale, so we just need to make sure we're plotting the same days. Just while I plot, I'm going to take that out, so it's one bit of code. Add that back in. Now, so you can see it's exactly the same day. And this is a really nice way of kind of looking at, and we'll go over this a lot more in week 3. And again, I can save this figure here if I wanted to. Okay, the final thing we're going to do, step 7, is just out of interest more than anything, is just to calculate the maximum tide. So find the maximum tide. So we've got 3 columns here. We've found the water level, we've found the maximum surge. Let's find the maximum tide. So again, I can just borrow this bit of code here. Now I'm going to plot this to row 3, but I'm going to replace the SU with tide in every instant. Okay, so let's run that. Now what's really interesting is the maximum tide is actually 3 meters and about 10 centimeters, and that occurred on day 157. So actually, if we run all of our code again, we can have a look at when that was. So 150. So yeah, that's probably the maximum tide there. So what's really interesting is actually when Hurricane Sandy occurred, it wasn't a particularly high tide, so the flooding could have been even worse if it had occurred on one of these periods. So the tide could get even higher. So the actual water level was 2.7. So that's the surge now. Yeah, so had Hurricane Sandy occurred on a higher tide, it could have been even worse. Okay, we'll stop there and then we'll come back for the final session in a minute.